Dear students, I am going to explain today numerical analysis cluster 3. The topic is numerical integration. Integration we had to find out in this analysis the method of finding the integral in the interval a comma b. The integral a to b f of x into dx is called numerical integration. In this technique we can find the general quadrature equation because of it is very important concept. Derivation of general quadrature equation in the numerical integration. How? Now we take it Newton-Gregori forward formula. Newton-Gregori forward formula, you know that y is equal to f of x, that is equal to y naught plus uc1 delta y naught plus uc2 delta square y naught plus uc3 delta cubed y naught plus and so on ucn delta power n y naught. And this formula can be expanded like this: y naught plus u into delta y naught, u into u minus 1 by 2 factorial into delta square y naught, and uc3 can be written as u into u minus 1 u minus 2 divided by 3 factorial into delta cubed y naught. Similar fashion you can expand it and multiply all this y naught plus u into delta y naught plus u into u minus 1 u square minus u. Similarly, u into u minus 1 2 can be written as u cubed minus 3u square plus 2u by 6 and so on. To find this integration, general quadrature equation, let us define u. U is equal to x minus x naught by h. From this equation, we will write down hu is equal to x minus x naught, and we will write down x is equal to hu plus x naught. Based on this equation, we will find out the limits for x. When u is equal to 0, x limit is x naught, it is lower limit. When u is equal to n, then x is equal to x naught plus nh, upper limit, because of u values in this 0 to n. And now we will take it the general quadrature equation. We will write down integral x naught to x naught plus nh y dx is equal to integral 0 to n y into h into du, and h into integral 0 to n y into du. And this is the equation dx is equal to h into u. From that equation u, we will write down derivation du by dx is equal to 1 by h. Now we will substitute the y values like above equation can be substituted in this equation, and we will take it integral for each part. For each part we divide that is the integral y naught du plus integral 0 to n u into delta y naught du integral u square minus u by 20 delta square y naught into du, like that. We will write down that equation, and separately we can integrate. We get it the equation that is h into n into y naught plus n square by 20 delta y naught plus half into n cubed by 3 minus n square by 2 into delta square y naught. You will get it that so on. This is known as general quadrature equation. Based on general quadrature equation, we have the following rules. One is trapezoidal rule, number 2 is Simpson's 1/3 rule, Simpson's 3/8 rule, Veral's rule. Now we go for trapezoidal rule. It is based on general quadrature equation by substituting n is equal to 1 and taking up to delta y naught. Then we have is equation simplified. Integral x naught to x naught plus h y dx is equal to h by 2 into y naught plus y1. Now we add it h1h both upper limit and the lower limit, like that we will get it h by 2 into y1 plus y2. Similar fashion, you add it 1h in upper limit and lower limit, it becomes x naught plus 2h, x naught plus 3h. Y dx is equal to h by 2 into y2 plus y3, and so on. We will write down the equation integral x naught plus n minus 1h into x naught plus nh y dx is equal to h by 2 into y minus 1 plus yn. Adding up all integral, we will get it trapezoidal rule, like that equation. Now we move for Simpson's 1/3 rule. Here we substitute n is equal to taking up to delta square y naught. Then we will get it in the general quadrature equation. We will get it a simplified equation like that integral x naught plus 2h y dx is equal to h by 2 h by 3 into y naught plus 4 y1 plus y2, and similarly add it to 2h on both sides. We will get it h by 3 into y2 y2 plus 4y3 plus y4 and so on. We will write, finally we will get it equation h by 3 into y minus yn minus 2 plus yn minus 1 plus yn. Adding above all integral, we will get it Simpson's 1/3 rule. The equation is given like this. Now we move for Simpson's 3 by 8th rule. It is let us substitute n is equal to 3 and taking up to delta cubed y naught in general quadrature equation, so that we will get it simplified equation like this x naught plus x naught to x naught plus 3h y dx is equal to 3h by 8 into y naught plus 3y1 plus 3y2 plus y3. Similarly, add it 3h and both in upper limit and lower limit. We will get it again equation. All this equation can be added. We will get it Simpson's 3 by 8th rule. The equation is given and which is highlighted. Now we go for Weddell's rule. Weddell's rule, by substituting n is equal to 6 in the above general quadrature equation and taking up to delta power 6 y naught, then we will get it a simplified equation. Note that this can be written like 1 5 1 6 1 5 1, and that means first one is y naught and 5y1 plus y2 plus 6y3 plus y4 5y5 plus y6, like that we will get it simplified form. Similar fashion, you add it all this equation, then we will get it Weddell's rule. Weddell's rule can be written like this, which is known as Weddell's rule. And here h is the scale, which is upper limit minus lower limit divided by equal parts. Thank you very much for the students. It is very useful for third cluster 3 people.